It's the last part.
I just started a new lab though. Sorry.
I mean, just stay in the back to listen the last part.
Okay, sure.
Okay.
Okay. Good. Okay. All right, let's start. So I'll make some announcements first. So I think you got the email that has problem set, the first problem set. So the problem set will be assigned every Monday, and it'll be due the next. And the problem set will be graded based on the mixture of a merit-based system and an effort-based one. So you will get a point for each question of an assignment if you get the question right, and half points if you did not, but showed some effort. The total points will be translated into the overall percentage of score of the assignment, and all the percentage from the assignments will be averaged after dropping one notice grade. Any questions about the problem sets or no? All right, good. And for office hours, please you can book me to make appointments for regular office hours, and you may sign up for 1-2 consecutive 15-minute blocks per week, and group meetings are welcome. And you can walk into the office during the regular office hours to observe and participate in the meetings between me and other students. But I have to prioritize the needs of the student, if that makes sense. Okay, good. And those who cannot make it to the regular office hours should email me to make an appointment. And please come prepared with a list of questions. Any questions about the office hours policies or? All right. And let's cover some contents from the last lecture. So we covered matching last week, right? What is matching? What is the purpose of matching? Yeah.
To balance out your treatment and control group so you can't actually minimize.
Right. Yes. So the thing here is that so the primary purpose is to achieve conditional ignorability. It is noted as this one. So the potential outcome set is independent from whether you actually got treated or not, given some covariates. But let's back up a little bit. Okay. What is ignorability? Anyone? What's ignorability? Yeah.
It means that like the treatment group and the control group are equivalent. So as if like it was a randomized experiment, even though it wasn't.
Yeah. So so basically, ignorability is that the treatment group and control group are comparable or similar before even before getting treated. After treatment, it can be different, right? But before getting treatment, they should be comparable or equivalent in that sense. Good? Any questions? Nope. All right. Random assignments or experimental methods are the primary device or method to achieve that state or ignorability. Good. it is expected to achieve the ignorability, basically. Good. But what does conditional mean? It is basically that these two groups, treatment group and control groups, are comparable given some covariates controlled or conditioned. So as long as some covariates values are same, then you can achieve the ignorability. That's what conditional ignorability means. But then what is, there is a question. What is conditioning? What does it mean by given X? Anyone? Okay. So conditioning is basically, in the simplest way possible, it is holding certain values of X's constant. You are fixing some values of X to certain values. Okay. There are more than one ways to condition on variables or covariates. A representative one is linear control, right? Can you tell me how linear controlling works? I think I mentioned this a couple times before, but can you tell me how linear controlling works? You guys learned such one, right? So what does that mean by no, I'm not condescending. It's not just
That's a reasonable question. It's a
Yeah,
very
yeah,
reasonable
yeah.
question. Totally reasonable. We know.
Yeah. Okay, yeah, no. So my question is, what does it mean by race's effect on income when gender is held constant? When everybody's gender is different. Weird, right? It is really weird. That's how. This is how linear regressions control variables. Let's say we have outcome variable, income, and we have intercept, and let's say gender is subtreatment, and race is covariate, and there is residual. Okay. There is two-step processes associated with this linear control. The first one is regress. Oh, not Y. Regress treatment on X or covariates that you want to control for. Okay. And the second step is regress Y on E1, where E1 is basically is in the first residuals from the first regression. Oops. So there would be some residuals from the first regression, right? The outcome here is the treatment or the independent variable, and the x variable is the covariance. So there would be some residuals for each observation. Good. And then you are making a variable out of this all residuals. And then you are regressing y on E1. Why would you do that? To eliminate the linear relationship between t and x. That way, you are controlling x. Controlling for x, basically. That's how linear controlling works. So the beta 1 here is the linear relationship between y and t after getting rid of the relationship between t and x. This part absorbs, this part basically absorbs the relationship between y and t that are explained by the relationship between t and x. That's how controlling works. That's what controlling in linear regression. Am I making any sense or? Great. Questions? Confused? Yeah.
So that absorbs the relationship between y and t after controlling the t on x.
So in the calculation of beta 1 is basically the linear relationship between y and t after absorbing out the linear correlation between t and x. So that way, we haven't gotten to this point that far, but I think you have heard of confounders. No? Heard of that? Yeah. So that way, confounders are held constant, or by running regression on of y on E1, you are leading out this linear correlation between x and trig. Does that make sense? No? Good? Good? All right. But controlling in linear regression assumes the linear relationship between t and x. The only functional form that is assumed is the linear one. So it is a very weak control, I would say. A weak version of control. Okay. There are other ways of controlling, or conditioning on variables, or adjusting for variables. They're all synonyms. Adjusting, controlling, conditioning. Linear controlling is the most famous one, but there's another way of controlling, such as stratification. Stratification is exemplified by blocking in experiments and matching in observational studies. Let me give you an example with the exact matching. Let's say we are looking at income. Okay. And we are interested in looking at gender's effect on wages. This is average wages. Sorry. Gender's effects on wages, controlling for race. Okay. In exact matchings, you are only looking at white people first to look at the gender effect on income or wage, which is 20. And you look at gender effects for people of color only. Good? Because controlling means holding this variable constant, right? In this subgroup, in this strata or stratum, everybody's race is same because they're all white people. And everybody's race is different, but let's say people of color are good. Any questions? So that's how conditioning works. This is one of the ways of control. This is the exact matching. Good. So you basically average all of the effects out, and you would have gender's effects on income net of race. Any questions? Or all good? Yep. And there are other ways of conditioning, such as subgroup analysis. In this case, it's more of just restricting your sample to, say, white people or people of color. Just focusing on certain group of people and just measure the causal outcome. But for the sample. And then there's attrition, censoring, non-response, and sample selection. I will skip these, explaining these now. But if there are questions or issues that come up during the course over the semester, I'll explain what these mean. But for now, I'll skip them. Okay? I'm sure there will be some occasions of explaining what these. Any questions so far? Nope.
I don't know why that is exact matching.
Oh, it's exact matching based on race only. So this is the race. So exact matching is that so everybody's white in this group, right? So it's matching based on race. You're matching all of the cases based on race only. But if you include more other variables such as income quartile or parental wealth quartile, etc., then you would have more cells. Does that make sense? No? So so exact matching is everybody's race is exactly same, right? And then as long as they have exactly same race as the comparable group, right? Okay. Yeah.
Is this because you're inserting like a different variable that's another variable?
Oh, what? Sorry.
A different variable, like a different issue entirely? It's like, because you're not interested in race.
Mhm.
So then you can make race all the same so that you can find out information about the other situation.
Right. So basically, you are interested in estimating causal effects of gender only, while just conditioning on other variables.
So then it doesn't matter which race you make everyone?
Yeah. No. Yeah. It doesn't make the difference. It doesn't make a difference.
Even that exact matching means
means you need to match all the other variables.
So exact matching all the other variables means covariate, and then this is based on your theoretical decisions, right? In this case, I only decided that the only variable that should be conditioned on is race in this case. But obviously, this is not a realistic assumption, right? Yeah. So conditional ignorability is the state you want to achieve basically. And then you are assuming that what kind of covariance would be relevant to be conditioned on. Obviously, this is can be different from what actually how society actually works, right? So you're making an assumption that these are the covariates that are relevant to be conditioned. Good. Okay. So as I was saying, exact matching is also known as perfect stratification or direct adjustment. Okay. So the procedure here is basically explained in this in the previous example, so I won't repeat that. The primary strength of this method is this method of controlling is that it is not subject to functional forms in the relationships between treatment and covariance. In the linear regression controllings, we assume that treatment and covariance have linear relationships, right? And after controlling, so linear controlling is basically deleting out or absorbing out linear relations between treatment and covariance. But in exact matchings, literally all of them are, say, white people. So it does not matter with the function form because it literally has, all the same values for race. So you can. This is the purest form of conditioning and the strongest form of conditioning. Does that make sense? Any questions? Am I going too fast or no? All right, good. Awesome. But then there can be some limitations with that. I think we have talked about this in detail, but the curse of dimensionality is the limitation of this method. Okay? Which means that, so if you have race, income quartile, education quartile, or education level in 5 categories, and other things. And let's use the binary measure of race for now. Quartile, education. And then they do have 2 categories, 4 categories, and 5 categories. And then the combination of all of them would be basically a lot. So there would be a lot of cells. And then whether your sample has at least one observation or every cell may not be so realistic. In this case, exact matching won't work. I mean, it can work, but it's really difficult to work with. Good. Any questions? Nope. All right. And that's why you want to use propensity score matching. Not you want to use, but it's an alternative to exact matching to solve that problem. Okay. This has been the most popular approach to exact matching, actually. I would say for political scientists, it's not really popular for some good reasons. And I would say that the method is, for recent years, it had its heyday, and it's more of a, I would say it's less and less used for some reason. If you're curious about these reasons, I'm happy to discuss in my office hours, but for now, I'm just gonna do it that way, and it's one of the most popular approaches. Yeah. So what it does is basically to make a score out of multiple covariates affecting the probability of treatment. So this is called propensity score. Ex is probability of treatment given X. This is propensity score matching. Okay? This is propensity score. Or the probability of being in the treatment. Okay? Given covariates X. So based on the values of covariates, you are predicting how likely this person would have been in the treatment group. Okay. And then you create matched pairs based on the estimated propensity score. So the logic behind that is that based on these covariates, you have a similar level of propensity scores, or the likelihood of being treated, and then you consider it as comparable. So as long as they have a similar likelihood of being treated, then they are comparable. And then they happen to be treated, and one of them happens to be treated, and then the other one is not treated, even though they have the same or similar likelihoods of treatment. Does that make sense? So in that case, these two are comparable to each other, but then the outcome is different, and the only difference is treatment. And then you can say, oh, this is the treatment differences or causal effects. Does that make sense? Yeah, okay. So it's really creating some matched pairs. You're making pairs, basically. It's basically that, based on propensity scores. You're trying to find which will be similar depending on, according to the propensity scores you create. Good. There are two important assumptions involved. The first one is matching creates balance between treatment and control group in expectation. So the method is designed in such a way that they are similar. The two groups are similar in expectation or in the population. So in your sample, it might be not the case by two or two. So you want to check your balance in your table while not assuming that this is these two groups are common. Any questions about that? Nope. Are you guys following me, or is it too fast, or nope? All good. Okay, good. And then the second assumption is the covariates that were used for the construction of propensity score give you conditional ignorability. So what it means is that you are assuming that, say, parental income is the only variable that affects the likelihood of being in a Catholic school or a public school. But then, what if we have unobserved variable that we could not, there are not really in the data, such as parental aspiration, which is not really the same as parental income, right? Parental aspiration that was not measured in the data can affect the likelihood of being treated, and that makes not including this variable in the calculation of propensity score will make the treatment group, the control group, incomparable. So you have to make an assumption that, oh, parental income is the only variable that affects the propensity scores to make a causal claim. Good? So it's never, even though your propensity score matchings, you cannot fully confident about your results. There's always assumptions involved, so you have to be really careful about that. Good? Any questions? Nope. All right. Yep. If you don't have any questions about that, let's move on to Stata exercise. Okay. Oh, what? Yeah.
I just think it's true.
Okay, sure.
It was a little unclear in class that like this content concluded with some slides about balance testing. And there were these nice graphs and sort of talking through them. And I lost a little bit like the mechanics. Like I was watching the lecture online, so I could ask a question in the middle of it. And I sort of lost like the I know one should do it. But it wasn't clear to me in the example he was presenting when they're like, is it just like it's like a stated command and you do it and it's just a thing you do and you don't worry about like
Oh no,
and then you look at the
have
outcome
to
and you go,
like after looking at the results.
yeah, and then you go, well that's not
That's
balanced, so I'm
why.
gonna go add some more stuff in and see how it looks and you just
Right.
do that over and over.
Right, yeah, that's what we are going to do in the state.
Oh, okay.
So let's get that.
It should.
Yeah. Yeah, because of the reason. Yeah, I'll look at this. Oh shoot. Nope. So let's open Stata. And I think you got my email with the view files and the data file. So let's download all of that. Oh, just download. Yeah. let's not open the view file first, and then download all the files. And if you go to this PC, and there will be a U drive. So it's the U drive is basically the space, disk space assigned to you for your SSCC ID. And then go to the U drive and create the folder Social362. Anybody get any questions?
Yeah, I got good things. I got some safe reason reading. You want it? All this data sets.
Any questions? Need help? No?
And like download it.
No request that we follow.
Oh, you can do this if you want to. Yeah, so as long as you enter the right directory, then you're, that's good. All right, need help or? All good? All right, good. Let's open the folder and let's cut all of the downloaded files and then paste them into your folder. And open the do file in that folder. In the do file, it should be named ematch. We're starting with the exact matching. So and instead of the directory right here, delete that part. And if you click the this area with the directory, and you can copy and paste your directory and change the directories to all both of the lines. Local working directory 1 or local working directory 2. Any questions? Sure. Oh, this. Oh.
Did you guys, is that in file make sense, or is it a separate file? Okay.
And it says like local WD1, and then there's like a really long address there. Oh, it's in the last email he sent us.
Oh, okay.
Yeah.
Any questions or? Any questions? No way. Oh,
Is it in the power?
and if you type the wrong correct directory in,
No, it's one of
let's
those
put the
documents.
type the exit command right below the use command and execute that.
Hey, Jonghyun.
Yeah.
Sorry, I'm just having, maybe I didn't download the right things, but I have the
Okay.
problem set, the slides, and the.
Do files show all attachments?
Oh, okay.
Yep.
Oh, perfect.
Yep.
Run this whole thing.
Yeah.
It says this file is not.
Do you download it? Did you
Oh,
change
I-
your working directory?
This is fine. Instead.
Yeah.
Okay. No, because I downloaded it twice by accident.
Oh.
So.
What?
And then
So if you put the type the exit command and click the execute button, and it'll all execute all of the lines up until exit. Questions or need help?
What? Exit?
Yeah.
It is cool, you guys. It is definitely cool.
Any questions?
I realized it was on those, right?
Awesome. Good, good. So before moving on to the actual contents of the view file, I'll talk a little bit about data management part of the view file, or view file management. Very briefly, actually. So how I would start the do file is to basically type in the title, purpose, author, and date. And then the next task is setting up the do file. I won't explain what these mean, but if you're curious, I'm happy to teach you in my office hours. But for now, let's skip that. And then this is the how you can set up your working directories. There are more than one ways to do so, but that's how I would do the job. And the log command will give you the log file after you run some commands, and then the outputs and everything will be saved in the log file. Good. Make sure to have the same name for the log file as the do files. Okay. And then the use command is basically using the data that you want to use. And as you can see, there will be some variables in the variables window. Okay. So before going over the matching part, I'll briefly explain what this Cataneo2 data are doing, or what we're trying to do from this data set. We want to look at the causal relationship between MD smoke, or whether a mother engaged in prenatal smoking affects how this variable affects the birth weight of a child, okay, of her child. But then there is always other covariates that might affect both of them and make those who engage in prenatal smoking and those who did not incomparable. Good. For example, they might have different age, different race, different marital status, etc., etc. Okay. So here we are trying to exactly match certain covariates. Okay. The thing about exact matching is that it should be all the covariates should be categorical. So the first task you have to do is categorizing continuous variables. I won't explain too much about what's going on here because it's not the focus of our section. But basically, it's categorizing the age variable into quartiles. So from the 0 until the 25th percentile, all for basically the youngest mothers will have the value of 1 for this new variable, and then the oldest mothers will have the value of 4 for the new variable, new categorical variable. So we created an age pole that really represents the quartile of mother's age. Okay. And then the exact matching is starts with the command of key effects, nearest neighbor match, outcome, treatment, and comma ematch. And then the covariates you want to include as for exact matching. Great. Good. So yeah.
So in that eMatch, would we also add like interactions between variables too if we want to control for those?
Oh, if you want to include that interaction variables, you can include that manually. Like you can make a new variable by producing two variables, the two variables of interest, and then include that in the eMatch. But then interaction variables would not matter in this case, right? Because every variable has the same. So, for example, age is everyone has the same age as 1, right? And then race is everyone has the same value of 1. Then the interaction variable would be just 1, right? So it'll be pretty redundant, right? Yeah, in this case, yeah. Yep. Right. Interactions will be used in the methods for that. Yes. Oh, what? Why do we have to do that? Oh, we really don't do that. Then there would be, let's say we have 0 to 8, 80 as 8, right? And then it'll be basically each variable would have 80 categories. Does that make sense? Yeah, so it'll make the cells very scaled. So that's why you want to categorize them continuous variables. If you execute the do file, then you would get this table. The number of observations are above 4,000, and matches requested is 1. This is because of nearest neighbor matching, or sorry, 1-to-1 matching. But I'll explain what that means in the propensity score exercise, so don't worry about it. And minimum here means that there is a one cell with only 3 observations in the combination of these variables. Okay. And then in another cell, there is a little over 10,000 people in the specific cell or the combination. That. Does that make sense? Good. Any questions about that? Or? Am I going too fast or no? All right, good. Yep. And that was exact matching. And oh, sorry. Before moving on to exact matching, is basically estimating ATE or average causal effect or average treatment effects. And for propensity score matching, I'll explain more about that. But propensity score matching typically seeks to estimate ATT, which is average treatment effect on the treated only. I'll explain more about that in a minute. But for now, let's take 5 minutes and come back to the Stata exercise for propensity score matching. Okay? Good. If anyone has any feel about the introduction sheet, please do.
Oh, yeah. So using these variables, we created like a lot of people, and so basically that's like being allowed. So one of them, there was 3 matches, and another was 1,000. Or is it 1,000? Yeah, well, it could be because if you have a certain sample size, like with this, the number of population of 600, we conditioned only on race, which was the yes, no, white, marriage, which is just a yes, no, and then the age and which you can to 4 times. So there's a possibility of 8 different categories. So it is conceivable like everyone like 10 years. So like everyone got married in 20, 30. Most of the people are white, and most of the people are married. So a lot of people now. It's also the small one, probably be the older non-white people that are married, depending on what this sample was taken. I don't think it's matched. I think it's before. It's man. Oh yeah, yeah. So that's just the amount of people into the scene. So there might be like 7,000. So at least that's what you have.
Yes, there's a big, well, it was.
Sorry.
I was not, I was like, my head hurts. Oh, no. You know, you're living in the moment.
Yeah, so the total number, so our max here is like. So we established that this is based on marriage, age of marriage, race. So it's 1,000 people in this one category. And there might not be the same amount of treatment control people within that category.
At the same time.
Like 3. Yeah, as long as there's someone within the treatment control, there's at least one. So there's like 3 operations in this category. And then
Yeah.
if you divide it into like treatment control, you need to have at least one to get the treatment effects.
All right. Can you start? Good. Instead of opening eMatch do file, let's click the do open button in the do file editor. And then open TSM do file. And change the directories to U drive or directories you're working with. Um, Let's open PSN, view file, and change the directories. And put the exit command below the use command and see if that worked out just fine. Okay. So for propensity score matchings, you need a user written command called psmatch2. So there is a Stata Corporation established command as well for this kind of matching, but it has psmatch has more attractive features. So we're going to focus on that command. So to be able to use that command, the user command, you have to install the command on your computer first. So that's why you have to type ssc install psmatch2. It's in the do file. You can just copy and paste it, basically. Then enter it, and it'll say it was installed. Data will say it was installed. Any questions? So far? Nope. All right, good. Okay, sure. Oh, yeah.
Oh, yeah.
What now? Let's see.
Sorry, we're gonna just run these two.
Oh,
No, I'm so sorry.
No, it's okay. I thought that was good. We're gonna go for
Oh.
so sorry.
No, you're good, honestly.
All right. If you are all done with the installing, let's look at the propensity score matching process. All right. The first task is to predict the propensity scores. Right? This is done by, I think, logit, the treatment variable, and covariance. So basically, you are predicting the probability of treatment based on the covariance of interest. Okay? And predict double score is basically saving a new variable called score based on the predicted probabilities from that logistic regression. Good. We haven't gotten to logistic regressions yet, but it's a regression basically. Yeah. Okay. So you are predicting the proclivity for someone to be treated or engage in prenatal smoking based on these covariates. Okay? And that's how we can calculate propensity scores. And the next command is ps-2. Let's look at the results first to explain it. So ps-2 treatment, MD smoke, all the covariates, comma, outcome variable is right here, and the logit is the functional form that you're using for calculating the propensity scores. So basically, you are running the logistic regressions to calculate the propensity scores. Okay. So, so the first table is the logistic regression results. So this is basically saying that this is basically predicting what kind of variables would be relevant in the propensity to engage in prenatal smoking. Okay. This table is not super important as long as we have propensity scores. Okay. Before explaining all of these tables, I would like to explain what the command does, basically. The default option of the command is 1-to-1, nearest neighbor, and match with replacement. So this command matches people or matches observations based on the propensity scores that were calculated based on the variance. But then this is basically trying to, from the perspective of the treatment group, treated observation. If you have one treated observation of, say, ID, one PS score is 0.8, and the outcome variable, let's say 20. Okay, and then PS score is 40, 30, 40, and then treatment is treated, controlled, treated. Oh, sorry. Treated, controlled, treated, controlled. So what you're doing in this method is that from the perspective of treated cases, you are trying to find a match you're trying to, find a good comparable case from the control group. Good. So propensity score matching is, according to its name, tries to find a comparable case by looking at the propensity score right there. So, in this situation, this case is similar to this case, right? Does that make sense? And so it means that they have the same proclivity to engage in, say, prenatal smoking. And based on the covariates we are looking at. And one of them happens to be treated and the other one happens to be not treated or controlled. And then for this pair, the treatment's effect is negative 20. 20 minus 40. Good. And these two cases are comparable, right? Based on the propensity. And then in this pair, the treatment's effect is negative 10, right? 30 minus 40. And you average all of the effects out, then you have the causal effects. Okay. Any questions? Cool. All right. And one-to-one, for the one-to-one matching, it means that from the perspective of the treated case, it is matched with only one controlled case. What would it look like when you have 1 to n matches? You are trying to find comparable, say, 5 control cases and have the average outcome for the 5 control cases and compare them. Compare the treated cases outcome and the averaged control cases outcome. Does that make sense? Any questions? No? Confusing? All right. And M to N case would be exactly the opposite, right? And I think N to M is straightforward in this sense.
Sorry, I didn't understand that. What is M? Is that like a certain number of treated to a certain number of?
Oh, so yeah. So N to a 1 to N is basically matching one treatment case with multiple controlled case to compare these two. And M to 1 is to calculate the average outcomes. You are averaging them out for the treatment cases and compare them with control case.
So M to N is a number of treatments averaged out to a number of M and N can be whatever value you're receiving.
Right, yeah.
Control or
Yeah.
What is the logic of doing that as opposed to?
So the nearest neighbor matching is basically, not nearest neighbor. 1-to-1 matching is that just you are using just one case to compare, right? But for that matching, it can be subject to one quirky trait of the control cases that happen to be matched. So they could be, so the control cases happen to be really similar to observed covariates as the matched treatment case, but then the outcome can happen to be really erratic. Does that make sense?
Yeah.
Yeah. So including more multiple observations would decrease that concern in that sense.
And then you do the same thing for treatment.
Right.
so-
Yes.
Is there a downside to doing end to end? Like, is there a circumstance in which it wouldn't make sense to do that?
So it can be problematic in terms of standard errors. There were some adjustments, and but the problem, this is a side note. So for solving problem set 1, it's not really critical. But just a side note. For standard errors, propensity score matchings happen to have larger standard errors actually, and then including more like M2N matchings. Using M2N matchings increase standard errors more.
Because you're reducing the absolute number of cases.
Right. Yeah. So and then there is like a lot of like codependence between the matches, basically. Yeah, a lot of like dependencies across matches, right? Because a lot of observations will be used for matchings more than one occasion.
So it's
Right. Yeah.
like with replacement.
Right. Yeah.
Okay.
Yeah. There is a lot of replacements going on. It's more likely that, right? In that case, standard errors have to be adjusted to be larger to correctly really reflect that dependence across matches. So in that case, even though the variable is significant, it's more likely that you fail to reject the null hypothesis. So that's the problem. Yeah. And the nearest neighbor matching is basically so there is this observation with the propensity score of 0.3, and you are finding the nearest neighbor from the controlled cases to match it. Okay. This is different from caliper matching that I'll explain in a few minutes. Caliper matching is basically for every observation that is, say, between 0.2 and 0.4 in terms of propensity score, you are matching all of them. Okay. Good. But what if there's no observations between the 0.2 and 0.4? There is no comparable cases, right? So it'll be deleted out in the estimation of AT. Good. Any questions? Nope. All right. Also, another thing here is that, let's say we have 2 cases. Okay. And then there's one case. If we're using 1-to-1 nearest neighbor matching, then these cases will be matched, right? And these cases will be matched, right? In terms of propensity score matching, propensity score, nearest neighbors will be matched. But what about this one then? It'll be deleted out in the estimation of causal effects, because it is not really comparable to treatment cases, any of the treatment cases. Good. So matching is really a technique of pruning in a way. Like you're deleting some observations out that are not really comparable. Good. And so that's why what is estimated here is ATT, not ATE, because incomparable controlled cases will be deleted out in matching. So that's why. Good. But sometimes treatment cases can be deleted out in caliper matchings, but we in this case we're using nearest neighbor matching, so none of the treatment cases will be deleted out. Any questions? All good? Yeah. All right. And then match with replacement is that one controlled case can be matched with multiple treatment cases. For example, if there is another case with the 0.32, it can be matched with this case with 0.3 and the treatment case with 0.32 as well. Good. Any questions? Nope. All right. All right. And then let's look at the data browser. So B weight is the outcome variable, and there's a bunch of covariates. But MB smoke is whether this person is a non-smoker or a smoker. This is the treatment variable. And PS match 2 dataset command actually created a bunch of system variables. Underscore P score is actually the propensity score that was predicted. The propensity score to engage in prenatal smoking. Good. Any questions? This is the propensity score variable. Good. And treated is 1 when this person is a smoker, and untreated is 0 or 0 when this person is a non-smoker. Good. Yeah. So there's a lot of non-smokers, but there are some smokers. Good. And on support is means that there is this maximum value and minimum value of PS propensity score for the treatment group. And there is this minimum value and maximum values for the control group, right? This is the support for the control group. this range is the support for the control group, and this range is the support for the treatment group. For these observations, they're called common support. Good. And so that way, support variable will have 1 for this observation, these observations. And for these observations, support will be 0 because they are not commonly supported. Good? Any questions? Nope. All right. And here's this weight variable. Weight variable is how many times this case was used for matching. So for the first observation was used for matching for 26 times. So it was matched with the 26 treatment cases. Good. Does that make sense? Yeah. And then there are some dots or missing values for weight variable. And it means that they're not used for matching. So they were just excluded from the analysis because they were not really comparable to the treatment cases. Okay. And notice that the weight is always 1 for treatment case because it was a 1-to-1 matching. So 1 treatment case was used matching for just only once. Right? And the weight is the B weight or the outcome of the matched case. Good. So for this person, for the 11th observation, the B weight is 3090. But the B weight underscore B weight or the B weight of the matched case is 2948. So the causal effect for this match is 142. So for this match, the mother who smoked had a bigger baby. In this case, in this specific match. Does that make sense? Any questions so far? And the ID variable is the ID variable that the PS Match 2 program creates automatically. And then this is the automatically created ID, and then and what? Oops. Or in I don't know. But this is the ID of the matched case. So the ID of the matched case is 1906, and then if we follow the data to find the 1906, then it'll have the birth weight of 2948. Does that make sense? So you can keep track of like which case was matched, and then what was the outcome for that matched case, and so on. And the NN is the number of matched control cases, which is 1 because it was a 1-to-1 match.
I follow the 1906.
Uh-huh.
Then I follow
Oh, what?
1906.
Uh-huh.
It's in the.
Where is it?
Oh, should I look at ID?
Yeah, ID.
Oh.
Yeah.
The real.
Oh yeah, yeah. You should keep track of what where 1906 is by looking at the ID. Yeah. Good. And lastly, the PDIF variable is the propensity score differences between the matched treated case and the matched control case. In this case, the propensity score difference was 0. The matched cases propensity score differences were exactly the same in this case.
So what just one more time, just want you to please, the difference between like the ID, the N1, and then
And N is
N, like what those are meaning.
oh, and one is basically the matched cases ID.
Okay.
So if you find a 1906 in the ID variable,
Oh,
then the birth weights this case would be 2948. Good. And then NN is how many cases were matched with the treatment case. And then in this case it's 1, right? Because it's a 1-to-1 matching. Good. Good. Now let's move on to the tables. So before getting matched, the average outcome of the treated group was 3137, and after matching, it's exactly the same because all of the treated cases were matched. Okay, from the perspective of treatment, we're trying to find every nearest neighbor anyways. Good, for each treatment. Right? So every treatment wasn't included, but then for control group, unmatched and ATT are different because some of the observations were deleted because they were not really comparable to the treatment. And some observations were used multiple times for matching. Good. And then this is the difference and the standard error, and the p statistic is right here. So PS match 2 is known for incorrect standard errors. So I definitely recommend supplementing the standard errors with the data you've established and But for the sake of demonstration, let's just focus on PS Match. I'm happy to talk more about comparing the PS Match 2 and Stata established commands in my office course. But for the sake of this class, let's just focus on PS Match 2. And if you look at the next table, before going over that. So the difference here is basically ATT right here. This is the amount of ATT, or estimated ATT. And this table shows how many observations are there. And there were a little over 800 treated cases, and then control cases were 3,000 something cases. On support means that all of the observations were on the support, on the common support area, basically. So there were no these cases. Good. And the next task is to check balance. Okay. The command is pstest, and then you basically include all the covariates. You include it. You used for the calculation of propensity score, and if you execute the command, let's look at the table first. Before matching, the treated group's percentage of married people was 47%, right? And the control group's percentage was 75%. It means that controlled cases were overrepresented by married women. Good. But then after the matching, the proportion of married women has been same. It became same. And then there is t-test to see whether there is a significant difference between the two groups, but you don't really want to see that because you are not looking at whether there is a statistically significant difference between the two groups. So you're not making an inference about the population. As long as it's the two groups are balanced in your sample, you're fine. It's not really about the population. Yeah. Balance is basically the distribution of covariates across these two groups are same, including means and variance as well. For example, age, this is about ages mean, right? But then this is variance of the treatment groups, the treatment group divided by variance of control. Okay? It used to be 0.88, which means that age of the treatment group has a larger distribution, higher standard deviation, right, for the variance, right? But then after the matching, they're exactly the same, almost. Does that make sense? Yeah. So it's just not about means, but also more about the distribution of the covariates in general. Dots are they're all like dummy variables anyways. So it is variance of them is subject to the means. So that's why there is no calculations. Good. Any questions? All right.
So if we're not using p-test as like a threshold for determining whether something is out of whack, is there like a threshold, you just kind of look at that and
Oh,
be like,
yeah.
that seems bad, like,
Yeah,
what's
it's,
your,
it's a subjective
yeah.
judgment. It's the substantial significance rather than statistical significance.
There's just a rule of thumb.
Right, yeah,
that
no,
you're
it's,
using, you're
it's,
just looking
yeah, kind of look at it and see what happens with that.
What happens when matching ends up making it less balanced? Because I'm just like looking, for example, at this like terribly named dead kids variable, and it says for unmatched cases they were a lot closer together than they were after they were matched. Is that okay if everything else is sort of matched up, or?
So I was gonna mention that, but let's just go over the next task. Yeah. And the next task, you have to for this line, you can just simply take a look at the results and see what happens. So I'll skip that. I think it's straightforward. And for the next task, you have to include some interactions and other variables that were not really used for the calculation of propensity score. Okay? To make sure that your covariates to calculate the propensity scores make them comparable, or assuming that there is no unobserved variance, unobserved variance of variables. So you are including a bunch of interaction variables such as age, alcohol, age foreign, age race, and age U, and you're adding this terribly named variable that is MNU, alcohol, etc., etc. And let's look at the results. Okay, so if you look at the table, then you can see, for example, for dead kids, they were not really comparable, right? In the mean, right? But then after the matching, it has worse. It has gotten worse, right? So it is problematic, right? So it means that they're really not. So treatment group and control groups are not really comparable in that sense. And then if you look at other variables, you can see that as well. This graph also shows how biased or how unbalanced these groups are. Even after matching, actually after matching, like the imbalance has gotten worse for these variables, for the variables that were not really used to calculate the propensity scores. Okay. In these cases, in this kind of cases, you have to include all of the imbalanced variables in the propensity score matching model. So you have to go back to the first step and include all of the variables that were not balanced in the covariance area. And then repeat the same process by adding more variables and stuff like that. Good? Does that make sense, or? Yeah. All right. Does that answer your question? Or?
Yeah.
Okay, yeah. And then the next task is to check common support. Okay, the command is psgraph, and the other is pretty straightforward. Yep. So what it does is basically these are all treated cases, and these are all untreated cases. And you're trying to look at whether they have common support in the sense that so in an extreme case of the violation of common support is when all the treated cases have this is not realistic, but the other case, the opposite actually. All of the treatment cases are in this area, and all of the control cases are in this area. In the nearest neighbor matching, this observation will be used to match with to be matched with all of the treatment cases, right? So it'll give you the APT, the estimated APT from Stata will give you that, but can we really say that it is this case is comparable to the treated cases? It's really not, right? You can't really say that. To check, to see if there is a violation like that, you are looking at this record. Seems like there is a common support.
Do you lock the door?
Okay, sure. Good. And then as a suggestive evidence, you can look at that, this table. Head weight. Head weight if and the smoke is 1. So for those who actually got treated, the weight is always 1, right? Because they were used for matching only once, right? So this is straightforward. But for non-treated cases, the weight has some distributions up until 35, which means that there is a case that was used for matching 35 times. So this case was matched with 35 treatment cases. Good. It is suggestive evidence because the fact that this person was matched with 35 people means that it is one of the possibilities, right? This lack of common support can be a possibility. Does that make sense? But yeah.
So based solely on that graph, because it was matched 35 times, would that conclude that it's not, those cases aren't comparable because it was used so many times? Is there a threshold there?
No, so it is suggestive evidence because so if this observation was used 35 times for matching. It is one of the possibilities. But then there is another possibility of just purely this person has, one person has 0.3 and 35 people have 0.3 as the propensity scores. So in this case, it is possible. So it is very suggestive evidence. So it can get you suspicious, but it's not a direct evidence.
Okay.
Yeah. So for the direct evidence, you are drawing a histogram of propensity score differences. Yeah. So almost all of the observations have 0 PS score differences. It means that the lack of common support is not a problem here, right? So everybody has the exactly same propensity scores, right? So the common support is there because they have the exactly same propensity scores. They share the support areas. Which is also can be guessed by looking at the PS graph that we just looked at. You know. This one. This is more direct evidence, and then PDIF is also another way of looking at direct evidence for common support. And so we have covered a little bit about that, but I want to introduce caliper matching as well. It is another option. So the default is nearest neighbor matching, but if you specify caliper 0.001, which is not really common, so it is either 0.05 or 0.1 that are typically used. But for the sake of demonstration, I'll use that. And the caliper matching is basically you're matching the treated cases and the control cases based on the distance. Okay? Okay? We're within the range of caliper. Okay. I'll leave it at that. If you have any more questions, let me know. But for the sake of demonstration and brief explanation of the method, I'll just leave there. Okay. And there is other matching methods like kernel matching and interval matchings and stuff like that. But for this class, I think nearest neighbor matching is what will be asked throughout the semester. Or problem sets and exams and stuff like that. And lastly, we can combine matching and regression, which is called doubly robust estimation. So it's basically running the propensity score matching first, and you run the regression. So you have the matched samples, right? After matching. With that samples, with that sample, you are running the regression of the outcome on the treatment, but with the control variables of other covariates as well. So that's why it's called doubly robust estimation, because you are conditioning on covariates by matching and linear controlling. Does that make sense? Yeah. Good? No? Good? No? All right. Yeah. Yep. So basically, after you match the observations, and then you run the regression of outcome on treatment with control variables as well. And this is the ATT, the estimated ATT within the regression, which is almost the same. So I guess this doubly robust estimation was not too necessary, but it's not too harmful to conduct for doubly robust estimation. So so it's one way to really think about how to control or condition on covariates. Okay. All right. Any questions? Nope. All right. Then I'll see you tomorrow in lecture.
Thank you.